the operations and signal. We're going to work on this signal the rest of the class. We'll take this signal as an example. X of t is defined that's -4 at t -4. Before that, any time less than -4, the value will be equal 0. And at t equals 6, any time greater than 6, the value will be equal 0 for the function. From -4 to 0, it's gradually increasing up to 4, so the slope is equal 1. And then constant at 4. That's the basic the original signal. We're going to perform different operations on this one. The first one, we're going to learn about how we shift the signal right and left. So let's work together with this function. So say that 1, 2, 3, 4, that's -4. And anything be 0 behind that. 1, 2, 3, 4. That's the max. And then 1, 2, 3, 4, 5, 6. I'll make it a little bit bigger. All right. So now we're going to sketch signal. It's below -4 is equal 0. And from -4 to 0 will be 4. And after that will be 4 up to the point t equals 6. And we'll go vertical. And we'll go 0. So it's 0 here, 0. All right, that's x of t, the original. We want to learn the time shift. Time shift could be to the right, could be to the left. So time shift, you might try to find xt minus 2. So how we do xt minus 2? It means you are going to shift everything to the right by 2 units. I will do that. Let's take a copy of the same signal. That's the original one. So I will sketch the top of it. So 0 will, it's not right. Okay, so 0 will be 2 at 2, and 6 will be at 8. 8 will be straight line up to 4, and up to 2, and -4 you add 2 will be -2. And then you will make a straight line like that, and 0 like that. So you would shift by 2 units. So when you say minus, you move it 2 to the right. What about if it's xt plus 2? What you'll do? To the left. I'm not going to do it like this, just to move it to the left. -4 will be -6, 0 will be -2, and just the same thing. Call this time shift. Okay, let's go to the second operation. So that's time shifting, and the same thing for the discrete time signal. If you look at the same signal, it's just sketched in the same way, and you make the shift by n this time. So -4, it was 0. If you move it to the right, it will be like that -2, you move it 2 to the right, so to be 0, and then at everything will be moving like 2n, 2n, 2n. So instead of time, will be n. That's all. It's the same. Now we'll go for time scaling. Time scaling. Time scaling, what does it mean, time scaling? I will go back to the original signal, that's x of t. If you want to do time scaling, will be something like that, x of alpha t, x of alpha t. Alpha could be greater than 1 or less than 1. Of course, if it's equal 1, no change in the signal. But when you have it greater than 1 or less than 1, will happen change. If greater than 1, what will happen if greater than 1? What do you expect? Actual decompression. Decompression. Like if you say x of 2t, so every single time will be divided by 2. Because anything having a -4, or you make, for example, at 4, if you look at that here, 4, now we have 2t equal to 4, so t equal 2 for the new coordinate. So you divide by 2. How we do that? Let's take also a picture for this one and make the it doesn't go at the right thing. Okay. Okay. We'll work on it. So that's x of t, and we want to do scaling x of 2t. That will make it compression. Why? Because we said that x of alpha t, alpha has two choices: alpha greater than 1, alpha less than 1. Greater than 1 will make it compression. I'm sorry. Greater than 1 make it compression, yes. And less than 1 will make expansion or stretching. Let's do the first one, x to t. It's alpha greater than 1 will make compression. So what does it mean? Usually I make a table for the important point here that it's changing here. So for x of t, you have -4, and you have 0, and you have 6. That's in x of t. That's the value of the time. When I do x of 2t, all the things will be divided by 2. So -4 divided by 2 will be equal -2, 0 will be 0, and 6 will be 3. So how we sketch it? All right. Let me do it on a clean graph here. So I have time t, and that's 0. So -4 will be -2. So I will have, that's 1, 2, so it'll be -2. 0 is still 0. And 6 will be 3. 1, 2, 3 will be 3. And the value of the amplitude of the function does not change. So obviously, when you look at both, that's x of 2t, and that's x of t. Obviously, it's compressed by factor 2. Can you do it by expression, yes, you can do, of course, by expression. What do I mean by that? Like if you find, this is easy, 4 does not change, but let's look at this function. This straight line, you know, of course, how to write this, the equation of this straight line from -4 to 0. You can write that x is equal to 4, and the slope is positive t. Check if this is the right equation. If t equal -4, the value is 0, that's right. If t equals 0, the value is equal 4, that's right. So that's the right equation for this straight line. So I will just check. I will say x of t is equal to 4 plus t for t greater than or equal -4 and less than 0. So how you do it? What is the equation of this one? Just let's look at the equation of this one. See what's happening. Let's discover what's happening. The equation of this one, x will be equal to 4. Well, this one is still 4. And the slope now 4 over 2, that's 2t. Right? So x, the new, let's just change the color, the new function that we did, I'm just working on this part, the rest will be the same. So x of 2t, it's equal to 4 plus 2t and t less than or equal -2, greater than -2 and less than 0. So what happened? Compare both equations. What you got here? If you want to find the mathematical expression for the new function, so what do you observe? Yeah, it changed. Especially the range is really important. The range, look at the range, what happened exactly. If you look at this function, and if you replace t by 2t, if you replace this t by 2t, so you will have 2t greater than -4 less than 0. And you know, find t, divide everything by 2. So what you get? T greater than -2 less than 0. So the secret, you replace every t by 2t and see what's happening. Replace t by 2t, what you get? You get 4 plus 2t. And that's your x of 2t. So can you do it mathematically? Yes, you can do it mathematically. You can do it graphically. So you should know how to do both. But graphically, it just can tell you you're right or wrong, and then you can check your mathematical expression. So if you are asked question how you find the expression, I will do the graph to make sure that I'm getting the right expression. So that's compression will multiply by integer alpha greater than 1. What about if you make it alpha less than 1, like 0.5? Expand, exactly. Expand. So you do that. Let me just quickly just, it's just the opposite. So I say x of t over 2. I will do first the graphical method. You know, our measure point -4 and 0 and plus 6. That's what I have. That's what I have the x of t. X of half t, I'll multiply it by 2. So you got this -8, 0, 12. So you can imagine when you sketch it, you'll find it's expanded. It'll be bigger, the interval. And you can do also the mathematical expression by the same way. You replace every t by t over 2. So for example, if I want to do this straight line, I would say x of t over 2 equal to, I will look at the main equation, 4 plus t, that will be 4 plus t over 2. And the time t was from -4 to 0, I will say the time over 2 greater than -4 less than 0. You multiply by 2, you find -8, and that's what I expect. That's what we multiply. You find just expanded, stretched. So that's time scaling. So time scaling, you have two possibilities. One, compression when alpha less than 1. So the opposite. The same thing for time shift. We said, you say t minus, you move to the right, t plus, you move to the left. So these are the two important operations on the signal. Of course, when you do the time scaling, we said alpha greater than 1, less than 1, but you do not go to the negative. It's greater than 0. You don't go to 0, or 0 nothing, and you don't go to negative. Negative will have another thing I'm going to explain. So it has to be positive. Alpha should be positive. Remember that. Time inversion. What does it mean, time inversion? As explained here, you replace t by negative t. So what you get? And you see from the graph the result, reflection on y-axis. Yes, reflection on y-axis. So if I go to the main function there, that's the main function. And you want to make the inversion, time inversion. So I make reflection. Let me just use this color. So -4 to 0. So -4 will be 4. You can do this table for time inversion. I will have my point here for x of t. I have -4. I have 0. I have +6. So for x negative t, -4 will be 4, 0 will be 0, that will be -6. Reflection on the y-axis. So -4 will be at 4, 1, 2, 3, 4. So this would be here. And the reflection will be the same thing. So just I'll make like a mirror. Right? What about the this other part? T equals 6 will be equal -6. So I have -6 here. So I will continue the straight line up to 6. I go down and becomes 0. So all the thing that will be x minus t, and then you make 0. That will be reflection. Now we'll go for challenge. We learn the basic operations: time shift, scaling, time inversion. What about if you have compound operation like this one, 2t plus 3? It has everything. It has time shift, has scaling. So how can we do that? There are two approaches. I'm going to tell you about the two approaches, how we do it, and choose any one that you like. There is one I'm favorite. I will tell you about which one. But let's see how we can do that. 2t plus 3. I'll choose a simple signal so you can understand it. Let's take it small, like from -2, just change. That's from -2, 0, up to 2. Small ones who can control it. And you have here 2. That's x of t. What's required? We need to find x of 2t plus 3. Approach 1. You will get x of t, make the shift first, and then time scale. So in the shift, it's t plus 3 means you're going to shift everything to the left by 3 units, right? So say that shift by 3 and make this arrow, means to the left. Then after that, time scaling is 2t. So what's 2t, compression or expansion? Compression. So let's say compression by 2. This approach number 1. And I mean, I'm in favor of this approach. It was easy and never can do mistake. Well, I'll apply first the shift. So how you do the shift? Let me just do the math first. You have -2, you have 0, and you have 2. That's x of t. So you do the shift. T plus 3 means you are going to move everything to the left by 3. It means you're adding -3 to everyone. So -2 and -3 will be equal -5. 0 and -3 will be -3. 2 and -3 will be equal -1. So that's the main. Yes.
You always do the shift first before the compression.
Yes. There is another approach. You do the compression first, but I'm going to show you the other one. But this one, I prefer it. That's why I make the first one. So making the shift before the time scale first is really good. So now I'm going to, I have my table here. I'm ready. And I have the signal in front of me here. I know how to change. So I'll just go ahead and make the change. That's the time axis. And I have from -5 to -1. So even when I make this table and I want to sketch it, so I will take care of this, the space I have. I have say a -5 here, -4, -3, -2, -1, 0. Oh, you don't need more than that, right? Because up to -1. Good. And that's your y-axis at 0. We'll keep it. I will go for the signal. -2 now is -5 and -2 is 0, if you remember. And 0 was at 0 was equal to, so I put 2 at -2. I'm sorry, at -3. -3, I'm going to put 2, 1, 2. That's another point. So it'd be like that. And that will be 0 here. And up to t -1 will be vertical line. I have the value equal 2, and then after that will be equal 0. So that's x t plus 3. You see the shift? Happens shift. Now, what is the second step? Scaling. How you do the scaling? Well, you look at the number. 2 is greater than 1. So you're going to define every single t. But the question is t, the old or the new? What do you think? The new, yes. So my new time here, I have -5. That's what I have, xt plus 3, and I want to have x2t plus 3. So I have -5, I have -3, and I got -1, and now a compression by 2. So I divide every single thing by 2. So I have -2.5, -1.5, -0.5. And I'm going to sketch it. So do I make it a new sketch or make it in the top of this one? Make it new is better, not make big mass here. So, and I know it's from negative, I start from -3. Oh, that's not a nice one. Well, -2.5, it means -3, -2, -1, up to -0.5. That's it. That's it. Make it 0 here. So I can make the vertical axis, and that's t, and that's my final. Now let's look at it, how we do that. -2.5, that's between -2 and -3, that's the point, corresponding to -5. -1.5, corresponding to 3, I have to go to 2. So -1.5, that will be here, -1.5, I go up to 2. And then I make the straight line, and I do the 0 up to -0.5. Negative 0.5 is here. I go there. I make the horizontal line. I go down vertical line. And I make 0. And that's 2. Obviously compressed. Yes?
So we wouldn't have the height of the graph?
No, the height is not affected.
Okay.
Yes. It's compression. It will be the same thing like spring, but damage is the same. So that's the compound operation. Do you have any question on that? Let's go for approach 2. So we'll start with x of t. And this time we'll start by time scale. So it was 2. I want to find x, just don't forget 2t plus 3. So I start by by scaling. The time scale will be like x of 2t and the shift. Here is the difference. You will say x and you take 2 as a common factor. So what's left? T plus 3 over 2, which is 1.5. And that will be the shift. And that will be the scaling. I will sketch the original function, and we'll do together the second approach. That's x-axis, y-axis. And we'll go for, it was -2, the original, I'm doing the original, not change, up to 2, another 2, that's x of t. I do the first thing. That's compression by 2. So you have -2, you have 2, you have 0. -2 over 2 is -1. Let me prepare for the graph. I do the compression first. Then I have -2 will be -1. I have to make the table now or getting familiar with it. 0 is still 0. 2 will be 1. Right? And I just sketch the same thing. The height does not change. So I did the compression. Second step, I'll make the shift. Shift is 1.5. So let me just make the table. I have -1, I have 0, I have 1, and I will make the shift. The shift is 1.5 plus, so I'm adding -1.5 to everything. So -1 plus -1.5, what you get? -2.5. 0 plus -1.5 is equal -1.5. 1 plus -1.5 would be -0.5. Did I do it right or did I do any mistake? Oh, it's fine. Okay. So I will sketch this result. I have the x-axis here. Let me do the y-axis the same. And I will go ahead and do the result. So -1, -2, -3, so -2.5 here. And it will be 0 behind that. And that's -2.5, 0. 0 will be -1.5, that's 0, that's -1, -2, so -1.5 here. That's -1.5. I go up to 2, and I make the straight line. Then 1 will be negative 0.5, which is here. And I will do the straight line, horizontal. I go vertical, and that's negative 0.5, and then 0 here, 2. Let's go and check what it's the same, right? You got the same. So you got 2 approaches. Do you feel the difference? The difference, the first one, you make the shift, you don't take common factor, and then apply. The second one, when you make the scaling, so you got to do the common factor. That's the only difference. So it depends on the order, which order you're going to use. So how you implement it or apply. I want to make sure you understand. So I'll give you now practice to do the compound. Because if you can do the compound, you can do anything. So I'll give you 2 practice today to do. One practice, do that, and other practice a little bit hard. So let's start with the easy one. I will just sketch it for you. Practice. So every 2, they will work together. That's x of t. What's required for practice 1? Yes. Yes, that's negative 2. If y of t equal x of half t minus 1, find or determine y graphically and express yt using a mathematical expression. So every 2 work together. I'll give you 10 minutes, and I want to make it like neat. So every 2 work together. I don't want you to work by yourself. So you can discuss them if you have any. I will write the mathematical expression for the x of t, so you will know how you do the rest. X of t expressed as the first part from negative 2 to 0. This function straight line is equal to plus t, and you can check it. from t greater than or equal 0 less than 3, it's equal -2. For the rest of the graph, it's equal to 0. So that's the mathematical expression of x of t. I want, after you find the compound or the y of t, expressed mathematically too, after you do the graph. Okay. So I make first the shift 1, and since -1, I shift towards the right by 1. So everything will be added 1. So -2 -3 will go to 4. 1, 2, 3, 4. That's 4. And 0 will go to 1. So and I will have -2. And for -2, -2 plus 1 will be -1. So I connect. And that's 0. And that's 0. And that's -2. That's x of t minus. Then I have half t. That will be expansion by 2. So I multiply every single time here by 2. So that's x half t minus 1 multiplied by 2. So -1 multiplied by 2 will be -2. And that's 1 by 2 will be equal 2. 4 by 2 will be equal 8. 3, 4, 5, 6, 7, 8. That would be -2. And that's 2. And it's going to, obviously, the expansion here happened. And there is a fast way. Of course, there is a fast way. And there's one student here, fine, just, it's easy. Because what you're doing here, first you're adding 1 and then multiplying by 2. So you can do it in one shot. Save your time. What do you mean by that? You have -2. That's the main point. -2, you got 0 and you got 3. We're adding 1 and multiplying by 2. So when you add 1 to -2, what you get? When you add 1, you get -1. You multiply it by 2. Add 1 to 0 will be 1. Multiplied by 2, you get 2. Add 1 to 3 would be 4. Multiplied by 2 is equal 8. So you have -2, 2, 8. -2, 2, 8, and you sketch in one shot. That will save the time. Just I want to give you just one comment. I mean, there is a problem, and my student that they went to linear system, they tried to solve it and they didn't try it. Right? When you have negative, if you have x of -half t minus 1, you did something similar like that. Easy. If I do the same approach, let's do the fast approach. What you'll do, you add 1 and multiply by -2. Some people, they do it in 3 steps. They make the shift, and then they make the scaling and the inversion, because negative means inversion, right? But now understand what we do it. We go from left to right. I adding 1, multiplying by -2. That's all. So if you have the main point here in x of t, -2, 0, 3, -2, 0, 3. So first I add 1. You have -1, 1, 4. Multiplied by -2. What you'll have? You'll have 2, -2, -8. And if you sketch it, you'll find it's the same thing that we did last time, but just we make the reflection on y-axis. Did you get it? Understood? Okay. I'll free.